Assalamualaikum warahmatullahi wabarakatuh and have a good day to everybody. Now we are continue our topic in chapter 2. We have done basically the vector operation, the vector subtraction and vector addition before. So now we want to find, we are using this addition and also subtraction, we want to find the resultant force. So we have the, for example, at this hinge support, at the hinge joint at the wall, so subjected to there are two force subjected to this hinge, force 1 and force 2. So we want to find which the final direction of this hinge. So we need to say we want to find the resultant force of these two forces, F1 and F2. So we are using the parallelogram law to carry out to find the resultant force. So we have this F1 and F2. So we want we draw up the parallel force, the force 1 parallel for this. You can see here this force 1 vector. We can see here this one is what's so called, this one is the tail. So the tail of the F1, so you put parallel to each, and then the tail of the parallel of for the F1 you put at the head of the originally F2. Okay, so we draw here is F2, F1. So the other one is the F2. So you make the parallel to the F2. So the tail of the F2 you put the head at the original F1. So you can here you can draw up actually is a parallel diagram. So the origin is the point of the this so-called the point of the both tail. So you make the direction, the one line from here to the connection, the intersection of the both parallel F1 and F2. So here, so we need that this one is the blue color, this one is the resultant force. So you can draw up either with this triangle or the one at the bottom triangle, the upper triangle or lower triangle. So here we have the upper triangle point is the same. So you take lower triangle of upper triangle is the same. So this one is the F1, this one the F2, parallel of the F2. So here F1 and F2. So we have the resultant force here. So resultant force here is actually the vector F1 plus dengan the vector F2. So this vector is actually this Fr is equal to F1 and F2 plus F2 is not a scalar. This is as a vector. So you need to find the resultant force actually the vector F1 plus dengan vector F2. Okay. So this is the procedure of analysis. We have the sketch I have explained before. So the diagonal line of this one is the resultant force. So by using the how you want to analyze this triangle, so by using the trigonometry, so we are using this cosine law and then sine law. So we have the triangle here. So you can see here we have the triangle. So using the trigonometry, so we have this triangle which has three sides. The side A opposite angle A, the side B the opposite the side B is angle B, the side C the opposite of the side C is the angle C. So we have the cosine law. We can determine the either one of the side by using the both information A and C, A and B. For example, we want to find the C. If let's say we have the vector F1 and the vector F2, so we can determine the length or the magnitude of the C by using the cosine law, whereby we can determine the either angle and also the side by using the sine law. So this one, these are two formula, useful formula. C is equal to, for example, it's actually C square. C square is equal to A square plus B square minus 2ABC cos C. So we have C is the square root for the product of A square plus B square minus 2AB multiplied by cos C. Whereby the sine law is A over sine A equal to B over sine B equal to C over sine C. If you put the denominator is upper, is this denominator sine A over A is equal to sine B over B equal to sine C over C. So either you put A over sine A or sine A over A. Okay, so you see the example. One example using this parallel method and also trigonometry procedure analysis. So we have this example. We have the screw eye subjected to the full two force 1 and F2. So force 100 Newton by angle 15 degrees subject from the positive x. The F2 is equal to 150 Newton. is subjected to 10 degree from the positive y. So determine the magnitude and direction of resultant force. So by using the parallel method, parallelogram, so we have here F1, we parallel to up here, the tail of F1, we put the head of the F2, and then parallel F2 we put the tail of the F2 we put it at the head of the F1. So we can draw the diagonal line from this end to another end, this original end to final the created end here A. So it's as resultant force. So here we have the 100 Newton and 150 Newton. So this one is 100, this one is 150. So whereby the angle is a 15 and 10. So here is a 15, so it's a 10. So we need to find the resultant force, the magnitude, the magnitude of this length, and also the angle from this to the positive x. So the resultant force is calculated from the positive x direction, positive x axis. Okay, so we have here 15. So we have here is a 15, this one 10. So 90 minus 25. Why is 25? Because 15 plus 10 is 25. So this one is a perpendicular. So we have 90 degree here. So total up the from y to x is 90 degrees. So 90 minus 10 minus 15 is a 65. So the angle F2 and F1 is a 65 here. So when you have the 65, the opposite of error is the same 65. The total of the triangle inside angle is 360 minus 65 minus 65. So we have and then dividing by 2, so we can get this angle. So 360 minus 2 multiplied by 65 dividing by 2, you get 115. So here is 115, this one is 115. So we can, then we have done for the angle, so we can take another one, either upper triangle or lower triangle. So here we have the lower triangle, for example. So we have the 115 here, this one is 150, this one 100. So by using the cosine law, so we can find the FR. Okay, so FR is equal to product of square root of product of is 100 square plus 150 square minus 2 multiplied by the 100 and 150 multiplied by cos the angle, opposite angle of resultant force, 115. So we get there the magnitude of the resultant force 213. By using the sine law, you get the 150 dividing by sine theta equal to 212.6. Resultant force dividing by the opposite angle is a sine 115. So we can get the sine theta. The theta is a 39.8. 39.8 is the here inside. So you need to plus in a 15. So you plug 15 for the resultant force. The angle, the direction of resultant force is calculated from the positive x, not the theta, but you need to calculate the phi. Phi angle is from resultant force to the positive direction, axis x. Okay, so we stop here. So we continue the next session in the section 2.4. In the we need to resolve the force in the coplanar forces. Okay, thank you and see you again in the next class. Bye bye.